All right, remember, you're going to have to break vectors down into their components. So you better know how to do that, like we've been doing that for a while. What are the signs of fx and fy? Fx is going to be positive. Fy is going to be what? Negative, because it's down. X is to the right, though, so that's positive. Now, what does this mean? What does this even mean? Express fx and fy in terms of the f. Well, it means this. It means that for fy, based on that angle, that's the cosine. Cosine of theta is equal to the adjacent over hypotenuse, which means fy is f cos theta. And that's going to be negative. Now, sine is what you would need to use for the fx in this case, and that would be fx over, oh my gosh, what am I doing? Sine of theta, forgot that, fx over f, and that means that fx is f sine theta. So f sine theta is fx, f cos theta negative is fy. And again, that's all there is to that. Okay, my goodness, I just made about a half-hour video for the freshmen. That's why I'm running out of steam already. I had 2.5 hours worth of Zoom meetings, actually almost 3 hours. I've just had it. That's all there is to it. I've had it. Okay, we have a bus. I'm about to just tell you the answers, and then if you have questions, you can email me or something. Oh gosh, or I'll just do this. All right. We have a bus. I really don't want to draw a picture, but actually, let's do this. We have a bus. Tires like this. And here's the bus. It's a really short bus. I don't mean short length, I mean short height. So, there's the bus, all right? It's going this way. But what's it doing? Well, the motion map would say that we have a bus that is, let's see, going from 30 to 10 meters per second in 10 seconds. So it's going this way, I'm going to say, but it's slowing down. And then it stops slowing down, then it just goes the same. So just pretend that there's a second half here on the other side that goes constant velocity. This A is going to be negative for sure here. Over here, A is going to be 0 because we don't have any acceleration on that side. So the left side is the one we're concerned about. Let's see, what do we know? From 30 to 10 meters per second in 10 seconds, what is the net force acting on the bus? Well, okay, net force. Net force is this, okay? That is the net force. So do we need to know all the different forces acting on the bus? No. All we need to know is MA. If we know what MA is, then we know what the net force is on the bus. The net force is the total sum of all the forces. The amount of imbalance, if you will. So we need to know A. We know the mass. The mass is 12,000 kilograms. So we know M, we need to know A. Now, A is delta V over delta T. And delta V is final minus initial. Final minus initial. 10 meters per second minus initial over 10 seconds. What's 10 minus 30? Oh, negative. So see, we should have a negative 2 meters per second squared here. Does that match our motion map? Yes. Look at that. That matches the motion map. Negative 2 meters per second squared. F equals ma. That means that the net force on the bus is the 12,000 kilogram mass. Oops, I forgot a zero. 12,000 kilogram bus times our negative 2 meters per second squared. So we're talking about a negative 24,000 Newton force. So again, the force has to be acting in the opposite direction of what it's going to slow it down. Okay. B, what does a scale read for a 75 kilogram man in an elevator that goes from negative 6 meters per second to 0 meters per second in 2 seconds? All right. Well, let's pretend that the man's motion map is like this. Oops. It's supposed to be, oh my gosh. Okay. The man goes from negative 6 meters per second to 0. That means, well, in my opinion, that means the dude is going this way, but slowing down until it finally stops. That means the A is what? Up. If negative meters per second in an elevator, that means down. So it's going from negative 6 to 0. That means the elevator is going down and slowing down, which gives me an upward acceleration. Let's see, now what? Apparently I hit the save, or not the save button, the projects button. Took me back to the dang projects screen and stopped the dang thing right in the dang middle of it. Oh my gosh. I can't take it anymore. My brain is fried. It's like 3 o'clock and I'd like to be done. Okay. Where was I? Oh yeah. Force diagram for the man. Why not? So force diagram for the man, we have, we have force of gravity and, and force of the scale, because the man's standing on the scale. Now, why do I have the force of scale drawn so much bigger than the force of gravity? Because it has to be bigger. Well, how do I know? Well, look at the motion map. A is up, which means the imbalance has to be up, which means the force of the scale has to be bigger than the force of gravity. And that also means that the summation F of scale plus F of gravity equals ma. How about that? But what's A? We need A. Well, final minus initial. What's the final? 0 meters per second. What's the initial? Negative 6 meters per second. How long did that take? 2 seconds. What's the acceleration? I hope you see it. Positive 3 meters per second squared. Not, oh God. Oh, this iPad is killing me right now. Oh my, I swear. I am positive 3 meters per second squared. I hope you see that. Positive 3 meters per second squared. So what does that mean? That means we got to put this crap in here. 75 kilogram man. What's the FG then? Negative 750. So we have force of scale equals, no, plus force, oh my gosh, plus negative 750 newtons equals m of 75 kilograms times 3 meters per second squared. What does that give you? Well, add your 750 to the other side. 75 times 3 is 2 1/4. So the force of the scale has to be 975 newtons. Positive. Which matches what our force diagram shows. Okay. Now this next one, I'm going to erase this just because it's in the way. I don't even want to do this. You don't have to. It doesn't say to actually do it. It just says to what? Describe how you would go about finding the acceleration. Well, we got a box being pulled like this with a 100 Newton force at a 30-degree angle, and it's a 10 kilogram box. Force diagram, why not? Fg, Fn, which is smaller than Fg. Why? Because I have some Fs here that's acting in the vertical. And do we have a friction? Yes, we have a friction force. Remember, we have an Fsx and we have an Fsy. Summation equations. Oh my gosh, this is a freaking disaster. Ff plus Fsx. And what does that equal? I don't know. What does it even say this thing's doing? Dragged across the horizontal surface. There is a mu. There's coefficient of friction. 0.2. Describe how you go about finding the acceleration. Okay, so there is acceleration. Okay, so that is ma. And we got the vertical. Summation. Oh my gosh. This is absolutely about to send me over the edge. Summation of forces in the vertical. This is the y. This is the x. I have Fg plus Fn plus Fsy. And what does that equal? That one has to equal 0 because we're not accelerating up and down. We're accelerating in the x or horizontal plane. So, now what? I lost my MA. All right, now, you need A. You know M. Do you know Fsx? No, but can you find it? Yes, because you know what Fs is, and you know the angle. So you can find Fsx and Fsy based on trigonometry. So you can find this, you know that, you don't know this. You need the friction force coupled with this, knowing the M to find the A. Well, how do you find the friction force? Well, we do know this. We do know that the friction force is mu Fn. We do know that. Do we know mu? Yep. Do we know Fn? No. It's in this summation, though. We need that. If we get this, then we can find that. If we get this, we can find that. So that's how you would go about finding it. I suppose you probably want me to do that. Oh my God. All right, now I'm not going to go through the trig. I'm just going to tell you that the FSX is, oh, that's a laser pointer. The FSX is 86.6 newtons. The FSY is 30 newtons. No, not 30, you idiot. It's 50. Oh, I did this wrong. What am I doing? I need to erase that. $50 newtons. Okay, so now what? Well, put your crap down here in the Y summation. What's the G? That's negative 100 newtons. Because it's 10 kilograms, that's 100 Newton weight, which is negative in the negative direction there. Plus Fn, which we don't know, we'd like to find, plus Fsy, which is positive 50, which is 0. That means the normal force is what? 50. That's an equal sign, not a negative sign. So the normal force is 50. Got that? Well, now what? Well, we need that here. 50 Newton of normal force times 0.2 mu. That means the friction force is what? What's 2/10 of 50? Oh my gosh. So we have 10 newtons right there of friction force. That means, and the friction force is in the negative direction based on our diagram. So we have negative 10 newtons of friction force plus oh, sheesh. The FSX, which is 86.6 newtons, equals, oh no, 10 kilograms times A. So that is 76.6 newtons equal divided by 10 kilograms. I'll just do it all at once. And that equals A. And so A is 7.66 meters per second squared. Oh my gosh, all of that right there. So hey, I hope that this helped. Wow, this is long videos here. If you have any other questions, let me know. I mean, the test is going to have to be multiple choice. There's no way. I'm not doing it like we did before. I think it's just all going to be multiple choice. All of it. Like every last bit of it. So, yeah, it's just going to have to be that way. If you'd like to have a Zoom, I had a Zoom this morning with all of my freshman classes, starting at 10 a.m., 10 and then 10:30 and then 11 and then 11:30 and then 2 and then 12 at noon there. So we could have a weekly Zoom if you want. I don't know if you don't. I don't know. Looks like we're going to have like 3 weeks left of stuff. So anyway, I hope that this helped. If it didn't, let me know and I'll try to figure something else out. Be safe out there.